got to do that from Oh, yes. I do need a picture of the software file. Not to get the money back. Get the money back. Yeah. Yeah, there are too many QR codes. I do. But, you know. Good job. Very Did I? Yeah. All right. Well, I yelled at the people outside, so I think we can get started and they'll figure it out. Awesome. I am gonna tab you to the thing though, so that I can move that. All right. Awesome. Hello everybody. You're in the right place for San Diego Python. I'm David. I'm glad you're here. I'm one of the organizers. I want to thank Qualcomm for having us. Oh, I'm going to actually double check that I unmuted the screen. I did unmute the screen. That's important. Sorry. I did want to thank Qualcomm for having us, and specifically to Drew and Urivan, who helped like man the door, line up, everything. They're here to let people in, all that kind of stuff. So thanks to them for everything Qualcomm related. I also want to thank Cloudflare. Cloudflare bought the pizza, which is outside the door. Woo! Yeah. Cloudflare makes networks and websites faster and more secure. They provide awesome tools like web app firewalls and DDoS protection. They have R2, which is a S3 compatible storage, and a whole bunch more stuff. The Cloudflare network is absolutely massive. 95% of internet connected people are within 50 milliseconds of a Cloudflare node. And this makes your website fast and your network fast and secure for people all over. Check it out. The free plan is actually pretty generous too. The San Diego Python website uses it. So thank Cloudflare. And I think that's it. Yeah, that's it for Cloudflare. Awesome. Cool. I do have a couple, actually I think I'll put up this slide, I think. This slide's pretty cool while I talk about the other announcements. The Saturday meetup, it meets virtually. Check meetup.com for details. It meets virtually 10 a.m. You meet in Discord. So if you don't have access to the Discord, go to the San Diego Python website, sandiegopython.org, and you can join the Discord from there. I also want to note the schedule change for next month as well. So just like this month is on the third Thursday instead of the fourth Thursday, December will also be on the third Thursday. And it's a casual meetup. There's going to be no talks lined up. Don't come to Qualcomm. Nobody will be here. We're meeting at Regent's Pizza. So that's on Regent's, and I think it's 1 block north of La Jolla Village Drive, maybe 2. So check it out. All the info's on the meetup site. And it's just a casual meetup. We're just going to hang out, eat some pizza, talk some Python. We do it because usually December has historically been a very poorly attended meetup month, so we're doing that. I think it's the 19th of December as well, so it's already getting close, you know, like people are in vacation mode. I don't blame them. I want to be in vacation mode. Cool. A couple other announcements. The website, we have sandiegopython.org. This has links to all the stuff that is about San Diego Python. So the YouTube channel where this is being streamed right now, so it links to that. It's YouTube at San Diego Python. You can get to it from sandiegopython.org. The link to the Discord that I talked about. There's a jobs channel in there if you're looking for a job or your company wants to announce a job or something like that. Because, you know, there's 10 people in this room or so, or 15, and you can reach a lot more if you look in the channel, post in that channel, because many more people over the month are going to look there. And people look back through that channel too, so really cool. I did want to note some upcoming conferences and events. Pi Cascades is in Vancouver, March 21st and 22nd. That's an awesome conference. I haven't been there in a couple of years, but Pi Cascades is a great Python conference. It's usually kind of one track, one weekend. Yeah, awesome conference. And then they just announced that PyCon US is going to be in Long Beach next year. This is not for a while. It's May 13th to 19th. The main conference is May 15th to 17th. So it's a while, but it's in Long Beach, so it's, you know, in our backyard, relatively speaking. If you're thinking about speaking at the conference, you can get mentorship for your talk if you submit a draft by tomorrow. You don't have to submit the final one, but if you submit a draft by tomorrow, you can get mentorship on your talk. Otherwise, the call for papers is due, I think, December 19th. So actually, I think the same day as our meetup, or maybe the day before or something like that. So yeah, anyway, PyCon US, Long Beach, next year. It's going to be awesome. I'll be there. Cool. And then the most important of all announcements at the meetup. This is the most critical of all announcements. And the most important button on the San Diego Python.org website. So literally critical, largest button on the website. It is the Become a Speaker button. Critical. Literally, the meetup runs on speakers. You know, we're always looking for people to come give a talk in front of, you know, 15, 20 of your peers. Whether you're practicing for a conference, you're going to talk at PyCon US, you can give a preview here. Or you're just, you know, worked on something cool, you want to show it off, please, please, please give a talk. We're looking for people to give talks at all skill levels, so it's not, you know, something that nobody else knows. It can absolutely be something that, you know, there's people in the audience who know it better than you. That's totally okay. You know, people who are on our YouTube channel, people who come to our meetup, they're of all skill levels, so we want kind of the talks at the meetup to reflect that. So please, please, please become a speaker. You can sign up on the website. You don't even have to sign up for the next meetup. You can sign up for the next meetup. But I've found that committing to give a talk is the best way to make you actually prepare and give one. So please give a talk. Awesome. I think that's it for announcements. Cool. So without further ado, Jorge, you are our first speaker. Jorge's going to talk to us about floating point math when precision matters. I think I know what this is about, but I'll let you take it away.
Thank you. Thank you. Let me. Sure. Yep. Give me a moment. Let me move some things around here, and I will get us rolling. I'm going to drag you out of here because you already learned about Cloudflare. This is one of the joys of getting older, folks, is that your eyesight starts to go. There. That's what I wanted to do. Now I will close you and grab you over here. Excellent. So, this is yet another talk in my nascent series of irritation-driven development. Yeah, it's a little bit of a delay. So irritation-driven development is that I see something annoying me and then I write a talk about it. For those that don't know me, my name's Jorge. I'm a test engineer for a company called Insulet, which is just down the street physically from us. We test a mobile app. And as part of that mobile app, we have to test to make sure that at least some of the math is correct, because that matters to our users. And yeah, we found out that not all math is created equal. There are some maths that are different. And so here we're going to take a little bit of a journey in kind of what math is and why that matters to all of us. So let me drag my terminal over here. And I will maximize that. And I will go into the Python interactive shell when I can spell. Okay. So, how many of you, by a show of hands, would say that this is a correct statement? How many of you say that's correct? How many of you say that's incorrect? Well, if you ask Python, it says it's incorrect. The good thing is, because I'm a person that loves to help the community, you're both right. Both answers are correct here. And that's because I haven't set out the requirement for what is right. So why is this a correct answer? And that's because Python, like many other modern languages, especially those based on C, follow a standard for floating point types. And that standard means that some numbers can't be expressed exactly. In this case, it's the 0.1. 1/5 or 1/10 cannot be expressed exactly using the IEEE standard for floating point numbers, right? And I will prove that to you when I actually do the math, and you end up with, oops, sorry. Again, my eyes are going. 0.3 minus 0.2. You end up with that. And that's why that first statement is false. So this bit us on a test. The application actually behaved correctly. The test did the math wrong, which is really ironic that the app under test caught a bug in our test script. And it led to my irritation. So what's the answer? There's a couple of different ones, but there's one that's actually in the standard library, and this was my recommendation to the engineer that drew the short straw and got this ticket. And so that's to use something in the standard library called decimal. Now, I normally wouldn't import this in a script, but there's other things that I'm going to use out of this module, so I want to just import the whole thing. And so if I use decimal, now this will work. And now I'm going to create this with a string, because I want to avoid that whole imprecision that I had earlier. Oops. In the 3? Yeah, thank you. Again, for some reason that monitor is coming up blurry to my eyes, so yeah. Now that works as expected. So why not have every float as a decimal? Well, one, again, the floating point type is a standard for a reason. And that's if you want to use other languages like C, like Rust, like Fortran, for those that are NumPy, SciPy types, you need to follow, the floating points need to follow the same standard. But the decimal module allows us to do math like we learned in school, where this actually is the answer that we expect. So how precise is this? Well, the answer is not simple. So by default, you get 20, is that 28? Yeah, 28. 28 decimal, basically a precision of 28 points after the decimal point. You can change this. And I'm going to do something a little crazy. And I'm going to set this to a very large number. And we're going to try something. That's a billion. Billion with a B, as they're fond of saying in English. So Python allows me to set the precision here. Now, my favorite irrational number is 1/3, right? 1 divided by 3, which what we learned in school is decimal 3 repeating, right? So let's see what happens when I try. And if you know, please keep it to yourself, because I want to actually show what I found. All right. That's a lot of 3s. Still more 3s. And finally, we get to the end. So what's the constraint here? You're going to laugh, but the constraint is the amount of available memory on the heap available to the Python interpreter. So you can have a precision high enough that you will get an out of memory exception, right? And it depends on what else you have running, because that obviously the Python interpreter doesn't allocate its own memory. The OS is responsible for this. When I tried this in the office earlier and I had some other things open, I actually got an exception, right, which is kind of cool. So you probably don't need 1/3 at this level of precision, and if you do, let's talk about your life choices. But the option is there, right? So the other thing that you can do with decimals that's kind of cool is rounding, because eventually you may need to do math where you have digits that are not significant in your output. So for example, let's say that you're writing a financial application. In the US, at least for now, until inflation makes that go away, we have 2 decimal places after the $sign that we care about for display to the user. But for math, we normally have a 3rd digit that we use to carry, the remainders of certain arithmetic operations. And so for that, you can round. Now, how does rounding work in Python? Well, let me show you. Some of you may be surprised by this if you haven't seen this before. So if I round 1.5, what should that be? Should be 2, right? And it is. What happens if I round 2.5? I heard somebody say 3, and I love that you did that because it's also 2. Is this correct? Actually, yes, it is. Because Python uses something called banker's rounding. Banker's rounding means that when there's a tie, you round to the nearest even number. That is the default. The decimal class gives you other kinds of rounding. But if you try this with a float, this is what you're going to get. Anyone see why you may end up with a problem with precision somewhere if you're doing a lot of arithmetic operations on floats? And the thing is that every time that you do another operation, the magnitude of the imprecision grows, especially with division, just because of the way that floating point numbers work. And so now, let's try it with a decimal. And now let's just use an arbitrary number, and I'm going to capture this in a variable, and that's not what I wanted. 7.825, because we're going to, let's do this. All right, so it gives us back a decimal. If I want to round, and I want to just use some of the significant digits, the decimal class gives you a method for that. And it is helpfully called quantize. I can never remember that. I always have to go look it up in the documentation. Right? Apparently that makes sense to people that are math majors. I'm not one of them. So quantize, and now I need to give it what precision I want it to have. So you pass decimal dot decimal. And so we're going to round this to, well, we still have pennies, believe it or not. So we're going to round it to the nearest penny. Right? And oh, I also have to tell it how to round. Actually, I did this right. It's rounding. I'm hoping that I took my notes right. Now I'm having some serious doubts. What did I do here? Yeah, I'm missing a parens, aren't I? Decimal. No, I don't. I shouldn't anyway. Decimal dot 1.01. Rounding equals decimal round down. All right. I will need. Again, this is a part of my notes that I wasn't sure about. That's fine. The thing is that use the quantize function to round down. Or round up, or round to the nearest even number, or round towards 0. Right? All of those are valid rounding techniques. Decimals also work with numbers that may not seem like numbers, but that really are. For example, is this a number? Yes, it is. Anybody know what NAND stands for? Not a number. Not a number. It's also some very good bread that is made in some parts of the world. But yep, that's a different conversation. It's dinner time. Yep. How about if I do infinity, which I forget how this is. I think it's positive INF. There you go. Is there a negative infinity? Yes, there is. Of course there is. If there's a positive one, there's a negative one. So you can handle all these numbers using the decimal module, and the math will work. The one thing that you do give up is performance. The thing about floating point numbers and have them conform to a standard is that modern CPUs have a floating point unit chip. And you can just do those straight in assembly, straight on that chip. You don't have to do anything else. This is not written in that. So you do give up a little bit of performance. But in terms of your floating point numbers, at least they'll be correct, which I think in our particular application that matters. So wrapping this up, go back to my presentation. So all math has imprecision with numbers, right? And in fact, there are more numbers that are irrational than there are rational for people that are math people. Using scaled integers is a reasonable alternative. That's kind of what decimal does under the hood. Right, it works with everything as an integer so that you don't have a float to deal with, and then it just gives you back the number in the display. And then, yeah, look at the docs. There's a lot that decimals can do. I highly suggest that when your numbers matter, when you're floating, when your decimals matter, you have a built-in solution. As an afterthought, I found out today that I work on a project on iOS, and our project is developed in Swift. Swift does not have a decimal type. Our developers actually had to handwrite one. So we have a little bit of a leg up on at least on that side. So questions? Yes, so do you want?
What's the balance between using a cloud versus using a custom map storage?
Yep. So the question is, that's fine. The display will come up in a second for folks that are remote. So, yep. So what's the difference between using something like decimal that's in the standard library versus using a native type or writing a custom class? One, it is a tenet of my religion to not reinvent the wheel, right? In fact, that's one of the things that I found that is most annoying is that I wrote something that's already in the standard library or in a package we already have, right? So this works just fine. You can even subclass decimal if you have some particular use case. So that's you can get the normal advantage that we do with it with any class. Now the disadvantage is that it's a class, right? It's not a native data type, and so you're paying for it in performance. Our particular testing that we do in my day job is all UI driven. That is incredibly slow. Number calculations is not our bottleneck. Right. So that's a good question. Thank you. There's a question in the back. Anybody? I thought I saw one. Yeah. So I'm repeating the question for those that are remote. So the display that you see up there, you see a string. And so how are these actually internally handled? They're actually two integers. There's a significant part of the number that's to the left of the decimal point, and then an exponent. So it isn't a string. It only displays like one. If you ask a decimal what is its type, it's going to tell you it's a decimal type, right? It's an instance of decimal. The only reason that we have that displayed as a string is because if you use the float, you're going to end up with the same imprecision you were trying to avoid in the first place. And in fact, I can show you that, because if I try to create a decimal of 0.1, you guys are not seeing this, so let me drag this over. Right. So if you're asking, oops, why did I get a syntax error? Oh, thank you. I forgot to quote afterward. Actually, I don't need any quotes because I want to do this from a float. And this is just muscle memory talking, but you see, you end up with the same imprecision you wanted to avoid in the first place. So it displays it as a string because that's what humans are expecting. But under the hood, the mechanism is different. It's a good question. Thank you. Yes. Yes. I don't know. That's a great question, and maybe it's worth diving into the time machine and finding out. Yeah. With I know that with other things in Python, folks have kind of took a look at what use cases were out there and tried to fill the most common one. That's a guess, though. I honestly don't know. Yes. So the question was, if bankers rounding is expected, can I change the rounding method? Or the rounding, if for floats you can't. There's no way to do that. The only other argument that round accepts, if my memory serves, I'm free to be corrected because I have been wrong before, believe it or not, is the precision. So how many decimal digits are afterwards? Thank you. But decimals give you different rounding algorithms. Anything from the remote crowd, David? Okay. All right, that's all I have. Thank you very much. You're welcome. Yeah, let me. Actually, I'm going to just hide it, just in case we do that last time. Excuse me.
I'll just let you take it away. You can introduce yourself.
Awesome, thanks. Hobson Lane. I am at Tangible AI, back at Tangible AI. We're downsizing, but we still have some work we're doing every Fridays. Once I get these, oh, let's do the mirroring, sorry. There we go. Okay. Only 5 slides, but then we're going to have some fun. We'll actually do do some ragging. Where'd this slide with all our names on it go? There it is. I didn't go all the way back to here. So I'm Hobson Lane. I'm at Tangible AI, and I'm going to be talking about Privatera, private research assistance with a RAG. We work every Friday morning at 9 a.m. till noon at Murai Cafe in North Park. So come join us, and you too can be on this list of contributors. So Boo and Glenn are have been coming there for the past few months, and they're at the core. Boo's a data scientist. Glenn's a full stack dev. Grant is one of my students at Mesa College. He's also helping with that NLPIA2 Wikipedia package for scraping Wikipedia. And Guido, you could join this list as well. You're showing up at the meeting, but haven't gotten you to contribute yet. So I've got 5 slides, and then we'll have some fun. The package name, RD, I think I was called RAG Kit is what I called it last month, but unfortunately that name has been taken on Pipey, so I'm looking at Privatera or RD RAG. Right now it's RD RAG on Pipey, so you can pip install RD RAG. Research and development RAG for drug discovery. At least that's the ultimate customer we're working on. Though we have a different customer that I'm talking to in December. So last month, I talked about this chunking documents in order to get them into a database like MeliSearch for document search. You want to chunk things into small enough pieces so that when you give them to the LLM, it doesn't have too much information and start to piece together things that don't make any sense. So you want to really focus it. One of the key things I'm going to talk about to the customer in December is about how they're having trouble getting their LLMs to be reliable, to actually produce non-hallucinogenic answers to questions. And so one of the ways you can do that is by using a really, really small model that basically only knows English grammar and doesn't pretend to know things like spatial reasoning or temporal reasoning or anything like that. And certainly not math. Doesn't try to act like a calculator when it's just guessing. And so you make the model really small so you know it can't do that stuff. And then you feed it documents that are exactly what you want it to say. And the way you do that is with Google search. You know how well this worked because Google was giving you the exact direct answer that was precise with references 10 years ago before LLMs were even a thing. And they were using conventional NLP and really slow generative models. And now we can do it even better if you just make them smaller. And this is all running on my laptop. So it's a 1 gigabyte model with 1 billion parameters instead of the trillion parameters that are typical for the large language models these days. And I found a bug in this. There was a recursive loop. It was including the entire Wikipedia article, both the HTML and the markdown text, as part of the chunk, as within the dictionary. Because I'm updating the dictionary here. There's a line here that I've commented out, and I just need to go through a subset of the attributes instead of all of the attributes of the object to create a dictionary out of it, so that the chunks are actually reasonable dictionaries. You'll see an example of one of them in a second. The same thing. The other key thing that I've done is we've productized it. So now there's a service in Etsy systemd so that it launches every time. So Boo, I've given Boo a laptop that's a souped up version of this laptop. That's an AMD processor. Another key thing that we're doing is we're using the Vulkan drivers for video cards for a GPU. It's an integrated GPU with a laptop GPU, and it's blazingly fast because of these hard-coded drivers, these Vulkan drivers that they're using the shaders that are normally used for shading 3D models to do math. And it's super fast, and it's all open source, and AMD's the way to go. because they don't have all the bloat of NVIDIA. And it's a lot cheaper and less power hungry. And so that's where we're running our LLMs. And another advantage of that architecture is because it's integrated into the CPU, the GPU is, then you've got access to the system RAM as your video RAM. So instead of being limited to the 7 gigabytes or 10 gigabytes available to you on a typical video card, you've got all 64 gigabytes of your system RAM. Then you've got, let's see. And this, so for Search, we've set up a service. Some of the key things here are, well, I guess the main thing here is it's quite simple. You just give it the path to where you want it to run and what you want it to run, and off it goes, and it runs every time the laptop boots. So whenever his cat steps on the keyboard and he has to reboot, it'll be back up and running, and I won't even notice that it happened. Same thing for the Llama service. So this is Llama CPP. That's another key thing. They have hard coded. They've done a lot of machine coding, assembly coding for the actual drivers to get it onto those AMD GPUs extremely efficiently. And we're using, this is the one that's on running on my laptop is a 1 billion parameter model. The key thing there is you can pick up any Hugging Face model that has that GGUF extension, and it'll work within Llama. Not just Llama, but any model that has been converted to this universal format called GGUF. And you're good to go. And you can run it on this Llama CPP code extremely efficiently. Chunking, we've already talked about that. I just have the wrong title on this. So another thing that I was meant to talk about, and I just titled this wrong. This is not chunking. This is about crawling a graph. So we're walking the tree of links, just like Google did when they were walking when PageRank came out, when Google was first invented. We're doing a PageRank of Wikipedia pages and doing it on the .links attribute of those Wikipedia articles in the Wikipedia API. And so I use that. There's some cleverness here. It's calling itself, and it handles. Types and I have a strange relationship, so I like it to accept either a string or a list of strings or a list of pages or a single page. And you can also give it the new thing since last month is we've added a depth so that it can go to a depth that you want in that tree of links from a particular location that you want. So I searched to a depth of 1 on virus, the article on virus for the biotech searches, and a depth of 1 on Africa for a trick question about Nairobi. And so let's do it. So like I said, I've got it in 3 places. Let's see, which one is this? So this is locally. Actually, I think I've got it. This is the one I want. Same one, but okay. So it's 14,000 articles that are related to virus and Africa. So there's a lot of 14,000 chunks. So typical article might have 20 chunks, sections basically in the Wikipedia article, and so you can do a search on virus, obviously. And if you put in a search like what is a virus, this is just the search engine you're looking at right now. So you can see that it's not going to come up with good articles that are going to like the trick question was, what is the size of a virus? It's not going to come up with the right chunk. So if you look at all of what's in, so I'm only giving it the very top answer. I'm only giving it the top 1 answer. So it's really focused on the best one, and it's not the best one if you pass the entire article into just a normal keyword search engine. So you can do semantic search to fix that, or you can do some just easy removal of stop words from the beginning. So if you just remove what, is, and the, then all of a sudden it gives you better results. And you can see that it's happening instantaneously in milliseconds. So typically a semantic search takes multiple seconds if you're lucky and you have a really big computer. But I like the responsiveness of typing and seeing as I'm typing the articles come up. And so this glossary might have something, but I doubt it. So it's still going to be a trick question. It's going to be a difficult one. We're going to ask it in a second and find out how it answers it end to end. And you have access to the Llama CPP language model directly. So you say, what is the size of a virus? And it'll make up some answer. And you, like I asked it earlier, what's the capital of Nairobi? Of course, Nairobi is a city in Kenya. It is the capital of Kenya. I wanted to see, shoot. This looks like it is broken. Okay, there it goes. There it is. So this particular model did well. The previous one did not. So it's not technically correct. A city can't be the capital of itself. But anyway, hopefully the RAG will do a little better once it's given a Wikipedia article on it. So that was locally. That's what's happening locally. So that's my local host. You can see there. And this is on the server. For some reason, it's doing a little bit better in terms of bringing up the right article. This article likely has the answer we're looking for. I know that if you put like NM for nanometers, it's much more likely to come up with it, unless it's filtering out that stop word. But you can see that of is not being filtered out. So there's probably some more massaging we could do to make it better. And then this is let's see if it happens a little faster remotely. Slightly larger model, and it's happening, like I said, on elsewhere. Anyway, that model did something weird. And let's see how the local model does when we run it from the Python API. Let's see. Just quickly, I'll show you the history, so in case it doesn't work, you can at least see that I did do it earlier. So I did not, I wanted to show that when I did not give it any articles, I did not give it the article I give it a lot of articles around Kenya, but not Kenya itself. And then asked it that question. But then after so what is the capital of Kenya? It was not able to find the answer because it did not have the article named Kenya. So it gave the provided text does not contain any information. You want to test for negatives to make sure that your model isn't guessing when it shouldn't. But then once I did have, let's see, what's the next thing I asked? Okay, right. I don't know why it came up with a. Then I did an added Wikipedia pages for Kenya and Nairobi, and then asked that question again. And I'm just showing the answer, the text answer, and it's nice, short, succinct. It just said what for the capital of Kenya, it got it correct. And when you give it the trick question, it still got the answer correct. And then I prefer this answer to the one that was given directly from the LLM. Let's see if it can do that live. Let's ask it something else. Yeah, I'll just. I can also get the full response with everything, or if I just want the text, you can give that as an argument to it. Interesting. Let's see what we got. Pretty good. There must be an Oracle South Africa already in there. Let's see. How big is a virus? Somebody else give me a question. You got it. It's got to be something biotech or, a swallow's a biological organism. Holy cow. There actually are larger ones. There's a 400 nanometer is the largest one known to man, but that's a really good estimate. I think the smallest ones are 10, so 20s. So 20s, and I think they're actually called prions when they get that small. But anyway, 20 is good. I'm impressed with myself. Let's see, what else we got? You wanted a swallow. How big is a swallow?
What's the airspeed of an unladen swallow? This is a Python video.
I know. I just know that it has no information at all about swallows, so awesome. This is everything, the context it came up with. So you can see the full prompt. I'll also do that as well. Just so you can see how it asked, how a RAG works. So I'm putting the context in JSON within that indented format, but I think if I make it XML or something a little less structured like Markdown, I might actually do better. It loves Markdown, these LLMs, because they've read a lot of Markdown. It does talk about things that fly and airspeed, but of course this is for some aircraft or ship or something. So the article wasn't at all helpful. And so it said it didn't know the answer. There's a lot of things we can obviously do to improve this to make it say something at least interesting or give you feedback on how you can correct ambiguous questions. Let's give it somebody give me a more serious question that is biology related that would likely be on a page related to virus or biotech. Or we can add a page. We can add a bunch of pages. You can at least see the scraping happen.
How many people died from COVID?
I wonder if that's on the Wikipedia articles. Oops. It's the wrong one. Here's the answer. Oh no! Talked about brain cells, but not about people. Let's change the how many people. You said people, huh? Oh well, it didn't do well. Let's see what happens if we just ask the LLM directly. Thought there was a way to ask the LLM directly, or complete with LLM. Because it'll make up an answer, and we have to go to the pages and see whether there's something actually truthful about it, or if there's any answer like that on Wikipedia in the pages that I've gotten. I should go to this. I'll go to the Melly search in just a second and find out. Complete with LLM. Well, it's taking its sweet time. This is a 1 billion parameter model running on my laptop while we're displaying. Oh no, that is the full thing. So it's only given the text for some reason. Oh, because I didn't say that. Oh yeah, it'll make up references. So these articles, I checked some of these articles. It even made up some Wikipedia articles that don't exist when I asked it that question about viruses. Well, the World Health Organization .int, that probably does exist, but I doubt it read them. I wonder if this one exists. But anyway, it tried. It tried much more enthusiastically than the RAG did, which is exactly what you want. Because you're trying to keep it from guessing. Because there's no way this tiny model has that number hidden in its data bank. Okay, cool. Let's find out if that's correct, and I'll look for the number on Wikipedia. Cool. They must have trained this particular model on a lot of COVID facts. Let's just see. Why is that? Wow. The numbers aren't going to show up. Just put it in the keywords. No, I shouldn't put it in the answer. 2019, the first person died. 25 million in Europe. Oh, Black Death. Yeah, you're right. I guess maybe I should look and see if the COVID articles. Yeah, so this is the title of the article, and this is the section that the chunk is from. So this is talking about it's looking for answers in all of the Africa articles that I uploaded. So I need to crawl the web some more before the RAG's going to be able to answer that question. So I did okay by not answering the question because it didn't have the info. It could have answered about Black Death and gotten it wrong, so that would have been. Any other fun you want to have with RAG?
We have one from the chat. Jeremy asks, how many known phage virus strains are there? Speaking Greek here, that's what Jeremy said.
Okay. How many known phage viruses?
Virus strains.
I didn't know phage was a virus. Are known?
Are there? We'll find out. Oh, whoa.
I'm gonna add these to our data set so that we have some positive and negative answers. Let's see. So we're gonna call this phage. It's trying hard. Oh no! Let's see what the prompt said. See what article it found, and I'll look for phage in the database. I don't think I added. Phage enters by looking. Let's see what the title of the article was. Lysogenic cycle. So it's all the. Let's go. Let's add the pages. Oops, that's not what I want. I'll add a few. Better not do that, not live. And I'll let that run in the background, and then we'll go to another terminal. Should I do that here? What the hell? No, that's not. Let's try. We'll try it in a second. Just a second. Well, it answered a lot faster. Now it's talking about herpes. What was the answer? Oh, hell. Let's see what the article was. I'm only asking for the top one. That's the other thing that we need to do. We need to actually search within the text that it provides and in all the top 10, perhaps, articles, and mash them together to create a smaller chunk that's more useful and focused on phage. And there's no numbers at all here in this article, so it's no wonder. Let's give the article, make it more focused. Y'all have to be getting bored. Oh no. That doesn't look good. What did I do wrong? Huh. I gave it a bad regular expression somewhere where oh. Maybe I'll put a question mark at the end, and I'm filtering out the what is and stop words at the beginning, and I may be doing that poorly. Shoot, sorry. Anyway, so much for YOLOing. I'll go ahead and get it started on, well, so it can at least get some work done while we're thinking. Oh, I know what it was. While I was sitting here, I was making a correction to the code, and I'll show you what I was doing. So when I had it going to a depth of 1, I forgot to actually chunk the current page, the root page that it's starting. I just added all of the, and let's look for, let's look for, what was it, dot links. So I'm adding the page here right up front. Oh, it is a Wikipedia page, and the links are not pages, they're strings. And so I've got mixed types in this list of objects that I'm asking it to add to the index. So what I should have done is made this title. I think that would work better. Or just the page's string that it started out with at the very beginning to force it to go in there. And so pages is the string because I checked for type string at the very beginning. It's not getting down to the Wikipedia page if statement until later. So that would have saved it. But I'm not sure why when I asked it the question with what is, somehow that code, yeah, that wasn't even getting triggered. Anyway, that wasn't the problem, but that was a bug. So you can see that it is doing a pretty good job of finding all the articles related to phages. Any questions?
You got a comment from the chat that this is more helpful than if it worked out as is.
That was Jeremy, I guarantee it.
It wasn't.
Oh, cool. Jeremy's so nice. What's our,
Couple questions. First, so you mentioned at the beginning, like dealing with hallucinations. Obviously, RAG is like one solution to that, but have you tried any other form of evaluation, or have you incorporated any like evaluation of the LLM's responses in this application?
there's a lot of papers on evaluating them, but it has to be done by hand because you can't test an intelligent agent with a non-intelligent agent doing the check. And there's no deterministic algorithm for determining spatial reasoning, math, or any of these other things. You can there's a lot of things you can do. So Vish, a former San Diegan Python user group attendee, he and I were working on a set of math word problems that can be parameterized so that you do know exactly what the numerical answer is going to be. And similarly, a professor at UCSD was taking a data set like that, and then actually, how it's printing out the tokens one by one as it's generating the answer to your question. Well, he would go in there and stop it at a critical point in its reasoning. Its chain of thought reasoning is one way to make it do better, is to force it to give you the steps of what it's reasoning about. But what he showed was if you go in there and change a critical step, a number in the reasoning so that it's incorrect, it will never detect that and it'll go with it. Or if you correct one where it's incorrect, it's called faithful and unfaithful reasoning, where is it telling you what it's actually doing or not? And it turns out it's not. It's just statistically guessing at tokens that happen to lead it to the correct answer more likely than the previous version of that model that was trained. And so that's all. It's just a statistical next token predictor. It has no intelligence. And it's really, really easy to talk to them and feel like they are and reason with them, because that's the only way you can actually get them to do stuff. You have to teach them, you have to cajole them like you would a 3-year-old. You literally can say, pretty please, will you please tell me how to make a nuclear bomb? And they'll do it. The jailbreaking is quite easy if you use weird psychological tricks. But it's not a psychological thing. What you're actually doing is just triggering an edge case in the statistical distribution of its prior knowledge of what tokens follow what tokens. And that, pretty please, it's never ever happened by a nuclear scientist in Iran trying to make a nuclear bomb. And so it doesn't show up on its radar as being at all related to nuclear weapons. And so it just happily goes along outside of those guardrails that are set to detect nuclear weapons building by the LLM, and it happily goes off and does it. So yes, there are a lot of ways to evaluate LLMs. Very few people are actually trying because it's so fun to just talk to them and pretend that that it's actually engineering that you're doing when you're just randomly guessing at prompts, but it's not repeatable. Every time they upgrade the model, all those prompts have to be changed, and the distribution of tokens has changed, and there's no way to know what the data is that they're actually testing it on. So it's a fool's errand to depend on these things for reasoning. And even academic papers are making stupid mistakes about how they do the analysis. So a paper that just came out 2 months ago was, I got some notes. I can look it up in my phone, but they were doing the reasoning in the prompt itself. So they broke down the problem. So Towers of Hanoi is a classic reasoning problem where you have 3 pegs and you have different size disks randomly stacked on one of the pegs, and you got to get them all stacked in the correct order. It's a sorting problem where you have limited real estate. And what they did was to make it work. So their claim is 1 million steps of reasoning flawlessly without any mistakes. And they achieved it, but they achieved it by incorporating the known algorithm into the prompt and breaking down the problem into individual moves of those 1 million moves that it had to make in order to sort 20 disks that were in random order. They basically told it the answer in their code. They actually wrote code to produce the prompt to tell it what to do. And they, with a straight face and an academic paper with lots of citations, they put this code and they admitted to it in the appendix of all the stuff that the trickery that they did. And they still claim that that's the way that we're going to achieve reasoning. But what you're doing is you're taking the reasoning out of the model and you're taking it out of your brain and putting it into software. And that's the way software is written. You cannot count on LLMs to reason. No matter how small the problems no matter how much you break down the problem into small reasoning steps. Because if you think about it, that last step, the trick to the Towers of Hanoi problem is you never pick up a disk and put it on top of a disk that's smaller than it. So you never put a large disk on top of a small disk. That way you can have a tower when you're done. Because as long as you pick whichever, there has to be at least one possibility of that move happening. So they told the LLM to do that. So all it had to do was to know that, keep track of this particular way that they were marking it, and the problem syntax, the way that it's a triplet of numbers. You say the ID number of the disk, and the peg that it's coming from, and the peg it's going to. It's a triplet of integers, and that's the syntax that it has to know, and it has to give you the correct 1 million ones of those triplets to get to that final answer. That's its only job. And they literally had a regular expression to check that it wasn't putting 2 double square brackets or nested square brackets, that it only had 3 integers. They were doing all of this in code and telling it to guess again whenever it got it wrong. That's the only way they were able to get it to work. And they had in the prompt on all of those slop prompt because it was an automatically generated prompt, but it was based on textbooks where this is known. You just take if you put a smaller disk on top of a larger disk, whichever one you can in that sequence of 3, you will eventually end up with the right sorting of disks on the left-hand side. There's a known algorithm, and they coded it up, and they included some slop prompting in their engineering prompt. Like, it's clearly stated that they told the LLM that the instructions are clear. That's in the prompt. That is not a logical statement. That is a judgment call about, and that's the kind of weird logic that people are starting to incorporate into academic papers at the highest levels of academia. It's crazy how LLMs are infecting us. Talk about viruses. Do you have any other prompting questions?
Well, I was just gonna ask because you mentioned that about like the search mechanism that you chose not to implement semantic search, but that could potentially improve the results. So what method of search are you using?
I'm just using conventional stack keyword search.
Oh, okay.
It's not even trigram full text search. So if I've made a typo, it would not find the articles. Like on Nairobi, I made a typo, a misspelling, and it had trouble. Are you familiar with vector search or semantic search?
Yeah, that's what I was asking.
Okay, got it. Yeah, so that's just extremely computationally expensive and memory expensive, and it doesn't scale to the size of all the biotech knowledge that exists, and that's the kind of knowledge that these drug companies in San Diego want to have at their fingertips in milliseconds, not in seconds. And so text search is the way to go. And we're doing this on a 16-core AMD 100 virtual core GPU. So we're getting by with a lot, and because they want it completely private. That's where private RA comes from. When you're doing really sensitive work, you want it to be completely private and on-prem, or as we say, on lap, because it's on your laptop. And we're hoping to federate it so that if you're doing research on your laptop, oh, cool. Oh, great. Yeah, they don't, I got throttled at Wikipedia. Well, that's that.
We got disconnected slightly, but it's okay. I think we're okay.
All right. Well, that was awesome, actually. I learned a ton, actually, from your talk. I mean, like, it's one of those things like where you're messing around and you're doing things that don't work out. You do learn a lot. Whoever said that in the chat, that was awesome. I think we're going to wrap it up here, actually. I don't think we need to do another talk. This was awesome. I do want to thank our speakers. I want to thank Qualcomm and Cloudflare, the sponsors. And I want to thank all of you who sign up to give a talk at a future meetup. Most importantly, please, please, please give a talk. So just a reminder, don't show up here at Qualcomm next month. You will be, unless you work here, in which case, by all means, show up here. But don't show up here if you're coming for San Diego Python, because you will be alone. Check the meetup, and we will be back next year. So thanks for coming. Awesome. Yeah. I think right when you wrapped up, by OBS crashed.